So the first one is scientific notation. We rarely deal with scientific notation in this class, but a lot of times you do in physics or chemistry where you have really huge numbers or really tiny numbers. So just to make sure you understand the process, if I have a regular number that is not in scientific notation, and I want to put it in scientific notation, everybody knows the decimal has to be right after the units digit, right? And then if I put it there, I have just made a really big number really small. So to offset that change, I go times 10 to the fourth, which is a big number, which would get it back to that. So a lot of people memorize these rules like, oh, if you move your decimal to the left, then it's a 10 to the positive 4. If you move it to the left, and something like this, it's a positive 2. And then if you move it to the right, it's a negative 3. And that's great, but let it make sense to you, because if you ever get on a test, you panic sometimes, you're like, wait a minute, what's the rule? Was it this, was it this? If you think about it, a really tiny number times a really big number gives you a bigger number. So to me, to have a negative 4 there doesn't even make sense. Because a 10 to the negative 4, what did you just learn that was?
Like 0.00001.
Yeah, that's an incredibly tiny, that's 1 divided by a huge number, right? So you don't want to take a small number and divide it by a huge number. That even makes it more small. So make sure you can memorize the rules like, yes, move it 4 to the left, go times 10 to the positive 4. Move it 2 to the left, times 10 to the positive 2. Move it 3 to the right, times 10 to the negative 3. Move it 2 to the left, that's a times 10 to the 2, but you already had a 10 to the negative 5, and then you, like bases, keep the base at the exponent. And you rarely see stuff like that, where they have the 10 to the whatever part, and they have the decimal in the wrong spot. But if you did have something like that, move it twice to the right, that gives you the 10 to the negative 2. If you've already got a 10 to the negative 5, like bases, keep the base at the exponent. Y'all with me? So we're not going to deal with scientific notation much, but it is in that course of study to mention. So you're going to have some problems. You'll probably have 1 or 2 on a test worth a point or something like that, where I ask you to put it in scientific notation or take it out. One thing I want you to know, though, if you have a calculator, if you ever get something that's so small or so big that they can't tell you what it is, the calculator puts it in scientific notation, but it doesn't say this. If you typed some massive number in and it dialed up scientific notation, it would spit out something like 6.421 E5. So just know that if your calculator spits out E5, and a lot of times the little scientific notation, little scientific calculators, they're like $10 from Walmart or whatever, they do that, that means times 10 to the 5th. Or if it says E, whatever, negative, if this said 3.564 E negative 4, just know that that means times 10 to the negative 4. And I don't know why they couldn't program it to say that, but that's what that means. And I'm not sure if your Inspire does a bad or a good job with that. It seems like they do it as well. Yeah, they put E20. So that would mean times 10 to the 20th. When I just typed in a huge number, it couldn't handle. Or make it handle, but it couldn't write out in those decimals. All right, and then SigFigs, I wanted to mention that too. If you get to chemistry or physics, significant figures or significant digits starts to become a big deal. Have y'all heard about these? In the olden days, you knew about them right now, but I think, are y'all taking chemistry right now, regular chem? Yeah, I think they cover it later, but they used to cover it earlier in the year. And significant figures are kind of like this. Like, richest guy in the world is who? Jeff Bezos. You know what his net worth is? I just looked it up.
Like 180 billion.
Give or take. It was 175 when I looked it up. So notice that he said 175. He said 180, right? I'll go with that. He said 180 billion. Now, is he really worth exactly that amount? No, probably not. I mean, I guess it's technically possible, but I doubt it. Stock market, I mean, this is a stock market valuation. He doesn't have that much in the bank, right? It's his Amazon stocks, his other investments, kind of what they're ticking at this particular time. Stock market's up, so he's up pretty well. His company's growing. But anyway, he's not worth that. But in Bill Gates or in the media's knowledge, this kind of stuff is insignificant. So what is significant out to maybe 2 digits is he's worth about 180 billion. Now, if I put this decimal on there with the 2 zeros, that would be suggesting that I am accurate all the way out to the cents. Are y'all with me? But if I don't put that decimal out there and I say, oh, he's about 180 billion. Saying 180 billion, even if the 180 part might be suggesting that there's 3 digits that are significant. I'm going to go back to my example of 175 because that's what I looked at. Just a second. So right here, just saying about 175 billion, I'm saying that this is not significant. I mean, think about that in your world. I'm not even going to mention the $300 million in his net worth, which would be life-changing money for all of us, even if I divided it up evenly, right? I mean, think about this. we're not even mentioning the 90 extra million that might be there, which again would be life-changing money. If we divided that amongst, what, the 8 of us, we walk out here with a cool 11 million, right? Buy us a nice little car, comfortable little house, invest the rest. We could live off the interest comfortably for the rest of our lives. Life-changing money, right? We're not even mentioning maybe the 7 million, which granted, 7 million divided by 8, that's going to probably be life-changing money for you. I mean, it's going to maybe be a game changer. Maybe I'll walk out of here and punt these 70-hour weeks, you know. But the point, I mean, $1 million's not what it used to be, but it still can provide a little income every year, you know, help you out. And even for you guys, I mean, like, what, 800,000? Serious money. If I handed you $60,000 right now, right? College, you feel a little bit more comfortable, right? Cars, pair of J's you wanted. 4,000, still significant to me, right? If I lost $4,000 today, if I had it in my wallet and somebody broke into my car, I'd be just furious. You know what I mean? I'd be like, ugh, I don't want to tell my wife about that. Now, we get down to this, 600 maybe, and I'm making these numbers up, 27, 600. Still, if I said, hey guys, I got 600 bucks, first come, there's gonna be a mad rush, right? Coming over the top of towns, 27 bucks, maybe you don't jump as much, 7 bucks, oh well, I can go to Chick-fil-A and get a biscuit and a lemonade. But my point is, to me, or to a lot of people, all of these are significant numbers. But when we talk about what is really significant, it just depends on our situation. Are you with me? People aren't going to go around saying Jeff Bezos is worth this much money right here because it's constantly changing, right? I can go pull up the stock market and you can see Amazon ticking up and down all throughout the day. Okay, and that's what's giving him his valuation. So how do you determine significant digits is important, and what you do in chemistry is much more than we're going to do here. Okay, but for the basic starter course, I used to have my rules, and my rules were a little bit more wordy. These are actually Miss Reeves' rules, if you've had her, or currently, or if you're going to have her in AP next year, whatever. She says, all right, for significant digits, the main thing that gives people trouble are the zeros. Because if there's a number, it's significant. I don't randomly say 175 billion if the 5 didn't mean something, okay? I didn't mean like, oh, psych, it's really 172 million. Or the 5's there for a reason. But all those other zeros, do I use them or not? So the zeros are usually one of the things in question. So to determine SigFigs, and I wrote down a bunch of options for you, here's what you're going to do. Always, obviously, any number is significant, and any zero in between those numbers are significant. So she says trapped zeros are always significant. So obviously, any number and any trapped zero, leading zeros are never significant. Now, we would never say a leading zero here, would we? We don't even put those there. But on decimals, sometimes you do have leading zeros. Okay? Well, these leading zeros are not considered significant. All right? And then finally, trailing zeros, like there's a trailing one, there's a trailing one, there's some trailing ones. They're only significant when there's a decimal in the problem. Which kind of makes sense, right? Because Bezos, if I have a zero right there, look, if I have a whole bunch of zeros, and I don't have a decimal, I'm kind of saying, I got about 175 billion, 397 million-ish. But if I put a decimal, now it's suggesting that I've actually known more, right? So if I put a decimal on there, all of a sudden you're like, oh, you mean you really have that amount. And if I start following it with more zeros, you're saying, oh, I really have that amount. So any trailing zero, you're going to count it when there's a decimal, but if there's not a decimal, you don't. So right here, if I look at this, how many significant digits do I have based on this model? Any digit and any trapped zero gives me those 6, right? Leading zeros, there aren't any. Trailing zeros, there is one, but there's not a decimal present. So how many significant digits do you have? 6. Here, any number or trapped zero, 1, 2, 3, 4, 5, 6. So I have at least 6. But then, and I don't have any leading zeros, but I do have trailing zeros with a decimal. So, well, hold on. Not only do I have trailing zeros, but a decimal is present. So if a decimal is present, I count all the trailing zeros. So it ends up being 7, 8. This one, I have a number at the front, a number at the back, and a bunch of tracked stuff, so I count it all. 6, what's that, 8 again? Here, I have 2, 3, and everything tracked in between. Leading zeros, never significant. So I am never going to count a leading zero. But I am going to count that trailing one. Why? There's a decimal present. So 5 significant digits. Number 5, definitely everything between the 2 and the 4, but never count a leading zero. So 4. Number 6.
I'm sorry.
Yeah.
So why do you not count a leading decimal when there's a leading zero when there's a decimal? What is that?
Officially, because those are the rules, to make common sense of it, I always had a little bit of a problem with that too. I always had a problem because to me it's like, you know, you needed those to show that value, but the actual digit itself, you could think about it in terms of scientific notation. I didn't really need those zeros to express it, you know? 1, 2, 3. But I have to be honest with you, that always bothered me a little bit too. Like if you put a decimal here, you're saying, oh, I'm exact to that value. You put a decimal here, you're saying you're exact to those values. Why wouldn't it be? It has bothered me in the past too. But I know that these are the rules, so I'm going to just stick to them. All right? Sorry, I don't have a more comfortable answer than that. And then over here on this, definitely the 2 and the 4 and everything in between. Definitely no leading zeros, but trailing zeros because there's a decimal present. So 6. 7, how many SigFigs? Or significant digits? Just 1 because there's no decimal. But 8 because there is a decimal.
Like 6.
6. Like this is saying I got about $200,000. This is saying I have exactly $200,000. Significant all the way to the ones place. Here, about. You follow me? Now in your book, just to mention this before I finish up, in your book, rarely does it talk about significant figures, but every now and then it'll sneak a problem on you, and it'll say, to 3 significant digits, what's your answer? And you probably won't even notice it when it says it, because you're reading this word problem and it says like, how many miles? And then it'll say, to 3 significant digits. And you're just working along and you come up with an answer like, I don't know, say you came up with, you know, it was 147.82 miles. And you're going to get this as an answer, and you're going to look in the back of the book, and it's going to say 148. Because to 3 significant digits, I'm going to round that and only use those 3. And you're going to be bothered by that and go, why? Or maybe it was something like 127,452 kilometers. And it says to 3 significant digits, you would come in there and round and say about 127,000 kilometers. And you're going to go, why are they doing that? I don't care. I'm never going to ask you after this to determine SigFigs, and I'm never going to ask you to write something in terms of significant digits. But you do this when you're in chemistry and other courses, because a lot of times, like if you had, if I told you that I had like 125.3 liters of something, and then I had something else that was like 5.1 liters, because this is only accurate to two significant figures, when I start adding these two together, my exactness starts reducing, because there's a roundedness about these problems. And you're going to learn other rules in chemistry about, oh, if you only have 2 SigFigs here, But then, or I'll make it even more clear. What if I said you had that many liters, and then I said you have 100 liters of something else? Well, because right here, I haven't been exact. I only have one significant digit. The way I would write my answer, if I added them or multiplied them, would be affected. We're not going to get into any rules like that. We're just going to learn the basic. We're not even going to be rewriting them. But I just want to caution you, occasionally in your homework, they do have answers. Not very often, once or twice, I think we run into a problem. And it's a good problem, so I left it in there. But just, you can ignore that. And don't worry, we play like everything matters. So if I tell you it's 1,000 miles, I don't want you thinking, now did he really mean about 1,000? Any value I give you, I mean exact in this course, all right? But I did want to just mention this so you kind of had an idea of what I'm talking about. And then to finish it off right here, number 9, how many? 9, because you would count all those trailing zeros. And then for 10 and 11, what do we have on number 10?
7?
No, I'm sorry, number 10.
Oh, 1.
Just 1, right? No leading zeros, so 1 there. And then right here, just those 3, because no leading zeros. You with me? So if you have that down, then you're not going to have any trouble with this. Every year I do have some people memorize their SigFig rules wrong. They memorize their scientific notation wrong. But if you just, and we're not going to do it again, so it's very easy to overlook this. I might not even mention it on the review. I don't remember. So it's very easy to forget all about this section because it's not as super important to me, but and to this course. But you might want to review it. Put a note to review that before your test because it's probably worth, I don't know, 4 points or something like that on your test. So this is what is important to me. So today we're going to be talking a little bit more about what we talked about yesterday, but the main difference is yesterday we were dealing with just monomials. So maybe I have something like this, 3x squared over 10x times, 4x to the 4th over 21x to the 5th. And these were monomials. And monomials, by their very nature, are already kind of factored, right? 3 times x squared, 4 times x to the 4th, 10 times x. And when I multiply or divide them, they're still just all multiplied, right? Everything on the top is going to be multiplied, everything on the bottom is going to be multiplied. But now we're going to introduce what happens when I don't have just monomials, but I have trinomials or binomials or things like that. Well, the same idea is in play. Right here, somebody tell me why I can cancel that 3 with that 21.
Because once you multiply them out, they'll be on top of each other. So.
Okay, maybe I'm asking a bad question. You're right about that. Why can't, I don't mean like why can't I actually do it? Because there's a factor of 3 there in the 21, right? So if it's factored, that 21, 3 times 7, and remember, to be factored means it's only multiplication in there. Because it is a factored value, I am allowed to cancel it. Because 4 is the same thing as 2 times 2, and 10 is 2 times 5. I can cancel a 2. And you don't have to write it out that way, but the point is people come to this, and they start thinking, oh, I can cancel an x out. Why can I not do that here?
Because it's addition and subtraction.
That's right, I'm adding and subtracting, which means it is not factored. Right here, this is super tempting. I see people all the time. Cancel. Equals 1. I can't do that. Why? Because it's not factored. As long as it has something added to it or subtracted to it, it's not factored. Now, that 2x plus 1, the whole thing is a factor, and the 2 is a factor, and the x on the bottom is a factor, but there's nothing in common there, is it? Right here, I might be able to do something to this, like can you factor that numerator?
Yes. X minus 1.
And if you struggled on the factoring test, you remember the factoring on this is going to be significantly easier than that factoring test, but you still got to know basic stuff. That's a perfect square trinomial, right?
Yes.
So that right there factors into x minus 1 squared. Now, the x and the 1 aren't factors, but the x minus 1 is. So I can cancel one of those x minus 1s with one of those x minus 1s. Or even better, cancel it and rewrite it. What's left?
X minus 1.
So I have x minus 1. Right here, can I do anything to this at all?
No.
No. Now, if that was a 2x plus 4, and I could factor a 2 out at the top, and then cancel the 2 out, like if that was plus 4, and you can factor a 2 out, because this is 2 times and that's 2 times, yes you could, but it's not. So I can't, so I'm done with this. This is as simple as I can get it. And by the way, if all of these questions are telling you to simplify, what does simplify mean again? PEMDAS. And PEMDAS does not have an F for factor. So why in the world would I bother factoring here? To help me do what part of the simplifying? Division. So if you look at it and you go, man, even if that does factor, there's no way it's going to cancel, then don't factor it. Like if I saw this, if I saw something like x squared minus 3x minus 4, which does factor, right? But if I saw that over 2x, you guys know enough to go, wait a minute. Even if it does factor, it's going to factor into 2 binomials, right? Are 2 binomials going to cancel with a monomial? No, then don't factor it. Because remember, factoring is not helping you simplify. It's only going to maybe help you divide. So if you can clearly see that it can't divide, don't bother. Even though the textbook might have it factored up right there just to make it look pretty for you, it is technically not simplified. All right, let's look at a few more of these. What about this third example? Can I do this? It's so tempting to do that and go 4x squared, or maybe 1 plus 4x squared. Can't do it. But what can I do if in the process of simplifying?
You can factor out a 2.
I can factor to help me divide. So if I factored a 2 out of the top, then the 2 and the x would cancel because now it's all multiplication, right?
Yep.
And I'd be left with a 1 plus 2x. Now what if I get something like this that has times that to the negative 1? Am I allowed to take this negative 1 and kind of distribute it into each part?
Yeah.
No. You know you can't do that. Think about it. What if I had a plus b plus c? Or heck, I'll make it. What if I had 2 plus 3 plus 4? If I gave you that to the negative 1, and that meant that you could do this, which you can't, but if it did, then that would suggest that you could do the same thing here, couldn't you? Wouldn't it? Which you can't, but if you could. And that would be saying that 9 to the negative 1, which you know is 1/9, is the same thing as a half plus a third plus a fourth. Are you with me? And I know right now that that's not equal to this. Right? I mean, 1/9 is way smaller than 1/4, and I'm continuing to add to a fourth, aren't I? So I know this does not work. I can't do this. Now, if it was all multiplication in there, could I do it? Yes, that I can do, but not with addition. And this is addition. So what's the only thing I can do with that negative 1? What did we learn yesterday in the video?
You flip the whole thing.
I could flip the whole thing. So if I flip the whole thing, that's basically saying 1 over that. And if I have 1 over that, what does that effectively do to this trinomial? When I have this now times this fraction. What does that effectively do? Y'all staying with me?
Wait. Okay. So then you multiply it and it just puts the 1 in the front on top of the 1.
So it ends up putting this on the top and this on the bottom. Are y'all seeing that? So can you look at these and now look at that negative 1 and go, oh, the negative 1 means flip it or move it down, the whole thing down below. It's like a division sign. So if I say times something to the negative 1, I'm really saying divide by that thing, which just puts it down below. Okay, so now that I have it down below, anybody have any ideas? Can I cancel that 3x with that 6x squared? No, because I got plus or minus. Can I factor that numerator?
Yes.
If you are going to factor it, what do you think you might want to do to help you? Because I'm not used to seeing the big powers at the end.
Probably factor out an x to that one.
Maybe even a negative x to make that big power positive, and then maybe get it in a better order. Does that sound like a decent plan? If I take a negative x out of that numerator, that would give me a negative 3 at the end, a positive 5x in the middle,
And positive 2x squared.
and positive 2x squared. I like the way that looks a lot better. Y'all tracking with me? And then now what can I do to see if something factors?
factor the bottom one
and the
top
and
one.
continue with the top one. So let's just take a look at the bottom one. I know you might look at that and go, oh, I want to do the magic number. And the reason why I'm not going to is I don't have any options on that one except to go 1 and 1. So I'm just going to think, well, what would give me a -5?
5x minus 1.
So I got to break up the 6x squared. So it's either going to be 3x and 2x or 6x and 1x. Both of them kind of seem nice at first. But if that's going to end up being a +1, what would these signs have to be? Both negative or both positive? But they'd have to be both negative to give me that -5, wouldn't they? And that makes sense. Here's what people do a lot of times by mistake. They go 6x and x, 1 and 1, then they go negative positive. And they're like, why not? It's 6x squared. Negative 6x +1 is -5x. What's wrong with that? Well, tell me, what's wrong with it?
1 instead of 1.
That would give you a -1 at the end, wouldn't it? So sometimes it looks really good, but make sure you check the FOIL. So, okay, I've gotten that rewritten. And then for this one, 2x and x, and then guessing and checking, maybe a 3 and a 1. Again, putting a 3 on the first one and the 1 on the second one looks good too, but -3 means what?
Yeah, 1 has to be positive, 1 has to be
One has to be positive and negative. So how about +6, -1x? Would that FOIL out to give me this exactly?
Yes.
It's very easy to miss those if you're not careful. So did anything cancel?
2x minus 1.
That's right. So if those two cancel, you end up with a -x out front and an x + 3, and then a 3x minus 1.
Well, wouldn't you have to multiply that out?
Now, yes, technically, this book and is everybody with me on this? This book and me will allow you, if you had the factor to cancel, I'm going to allow you to leave these all factored. Because a lot of times you're going to end up with 3 or 4 factors, and to multiply all that out is terrible. So if you don't, once you're done, I know it says simplify, I'm not going to make you do that last bit of multiplication. And the reason why is most of the time in math, even though right now in Algebra 2, Algebra 1, you're just kind of doing stuff to do it, you're going to be solving equations. So most of the time this would be equal to 0, or maybe you took a derivative and it's equal to 0, and you're trying to find out the zeros of this, which we're going to talk about in a second. So you want it factored in the end. So I'm not going to make you simplify if you want to leave it like that. In fact, I would encourage you not to at the very last to multiply these back together. Oh, and another thing. If you look at this right here and you go, there is no way, even if it does factor, that it's going to cancel. Like if you see that there's no way that's going to happen, then don't bother factoring. Okay? Because again, you're only factoring to what? To divide. Okay? What about this? I've already factored it for you, sort of. Part way. You see anything you can do? Maybe help yourself?
Difference of 2 squares. And
Difference of 2 squares, so that factors a little further.
perfect square trinomial.
That's a perfect square trinomial, so x + 2 squared. Be careful about those kind of things. Now, does anything cancel?
There's 1x + 2 that cancels.
So definitely an x + 2.
And then you could do a -1 out of the.
So what he's processing right now is, does that and that cancel?
Yeah.
Now, directly, this is a big deal. It's going to cost you 4 points on your test if you're missing this. Does 4 minus 7 equal 7 minus 4?
No.
No. So if I have a 4 minus 7 over a 7 minus 4, for you to cancel them would be a little irresponsible, wouldn't it? Now, the reality of it is, though, they're not the same, but they only differ by a negative sign, don't they?
Mm-hmm.
So if you see like an x minus y over a y minus x, if you really think about it, you're always going to end up with opposites on the top and the bottom, which always end up giving you a -1. So when I see a 1 minus x and an x minus 1, if you want to factor a -1 out, which would give you a positive x and a -1, you can do that if you want and cancel, but I just cancel it, put a -1 in its place. So when I see an a minus b over a b minus a, cancel it, put a -1. So in the end, what do I end up with? -1 in the numerator, and I am not going to multiply these back together. I'm just going to leave the x + 1 and the x + 2 like that. But again, if you want to do it, you can, but I'm not going to be looking at that part of your work. Y'all with me?
I think we just did.
We did that thing, didn't we? Earlier? I asked you that twice? I have no idea. Okay, last couple things, domain and zeros. All right, I think we're gonna be in good shape on time. Now, we've actually talked about this already this year. So, let me remind you, what do I mean when I say domain? Be more specific. You said values of x? What about them?
Is it f at it?
What about values of x? How pretty they are?
What they equal?
What do you mean what they equal? If I want the domain of this, the domain of this problem, I want to know what x's
What x's would plug into the
would plug into there
and come out.
and come out with some answer that has value, right? Not an imaginary number, not an undefined. Now, how do you get imaginary numbers or undefined?
Square root.
So square roots that are negative give you imaginary. Don't have to worry about that here.
Oh, and then if there's zero on
Zero in the denominator, and those are bad, right? So if I want the domain, which are the good values of x, what would I have to say here to determine the domain? I want to know what?
What squares to equal, or what makes the bottom 0?
Perfect. What makes that 0? And then I don't want to count them. That's all that matters, right? If the bottom's 0, bad. The bottom's not 0, good. That's all I need to know about domain. So I'm going to set the bottom, whatever it is, equal to 0. I'll actually set it not equal to 0, and I'm going to solve that. If it factors, great. This one actually, do you remember what to do when you square root?
3.
We were talking about this in the video, I think. Miss Tyree said she used to, somebody was saying she used to scream at you. Don't forget the plus or minus, you know? But don't forget the plus or minus. Did y'all hear my comments on that?
No.
My comments on that were, people learn this wrongly. This is what they do. They go, true statement. But you know what it makes you think? It makes you think the square root of x squared is x. False statement. It makes you think the square root of 9 is plus or minus 3. Also a false statement. The reality of it is, and we'll talk about this more, is the square root of x squared is absolute value of x. And the square root of 9 is 3. But what did you learn about absolute value? You learned what? Sometimes it's positive, sometimes it's negative, right? And then if I move the decimal over, I get 3 or negative 3. So Algebra 1 teachers skip this because not everybody in their class is at your level. You look around, you've seen some attrition. You remember who was in like Colby's class or Tyree's class. It was some of you guys, and then it was, oh yeah, that's so-and-so. He didn't make the cut to Helmer's. Or he was in Helmer's class. He didn't make the cut here. So those guys struggle with this stuff. So Algebra 1 teachers kind of bail and they go, you know what, I'm going to leave that to Algebra 2 and pre-cal. And just don't forget the plus or minus. And they scream that out at you, right? So that's the reason why, but don't forget it. So, and also don't just tell me right here, if I'm solving this, you're welcome to just write this. Remember, not equal. Don't tell me that, hey, x can't be plus or minus 3. That's like saying, hey, what food do you hate? And you go, well, I hate Brussels sprouts. And maybe you love them, whatever. Does that mean you love everything else?
No.
No. So don't tell me what, hey, it definitely can't be plus or minus 3. Tell me it's everything, all reals, but plus or minus 3. Or even better, negative infinity to negative 3, negative 3 to 3, 3 to infinity, and that lists everything that works but the plus or minus 3. Are y'all with me on the main? Now, what about zeros? What does zeros mean? I mentioned this before. A 0, a root, an x-intercept, all kind of the same thing. So how do you find a 0? Do you remember?
Yeah, is it plugging the stuff in the numerator in it, or are you factoring in?
The short answer is set the numerator equal to 0. But what you're really doing is saying, when for a 0, I want to know when y is 0. So you're taking the y and you're replacing it with the big 0. But the short answer is, when are fractions equal to 0? What is any fraction?
0 over 1.
When you have 0 over a number, right? So the only thing that matters is that the top ends up being 0.
Yeah.
So for a 0, you really only need to be concerned with the numerator. So this was domain, but for zeros, I'm just going to take the top part, set it equal to 0, but that's the y of it. And then how would I solve? Got a factoring problem. And again, the factoring's not going to be brutal. but you might have some guessing and checking. In this case, 3 and 3 minus plus, so x is 3/2 and x is -3. Now there's one thing I need to really correct. This says the zeros, or basically the x values that make this whole thing 0, are 3/2 and -3. But what did this say? It says we can't even use -3. It says -3 here makes that undefined, right? So if it makes it undefined, then it can't make it 0, can it? So I really wrote these notes out. Right here, you need to add the zeros. The x values where the numerator is 0, if it's in the domain. And that is not in the domain, is it? It was excluded, so don't count that. This would be the only place where this fraction or this function equals 0. All right, so I'm gonna throw a curveball at you. If you can do this, you're gonna be in great shape. Look at this second example. Now think, don't memorize. What is the domain? Places where the x value
Has a value that's not
has a value that's not DNE or that's not imaginary, right? So it might be easier to think what doesn't work and then exclude those. So what's not going to work here?
2.
Be careful. What's not going to work, you're right, where that equals 0, bad, right? So not equal to 0. Factor it. Set each factor equal to 0, and I get x equals 2. So that's the first thing. But wait a minute. Isn't it possible to get an imaginary number with this?
Yes.
Now, when would a radical be imaginary again?
When it's negative.
Now, you said when it's negative. What do you mean by it?
When the product of the root is negative. So like if
Hold up. When is that? When you say it, what are you talking about? You talking about the x that goes in there? Or are you talking about whatever's underneath?
when what comes out is negative.
Whatever's underneath. If whatever's underneath comes out negative, ends up being negative, it's bad. So you want whatever's underneath to be positive or 0? How can I say that? Whatever's underneath is positive, but 0 works, right? I can take a square root of 0. Positive or 0. So you don't want these numbers, but you do want those numbers. Are y'all tracking with me on that? And then that's easy to solve, right? Add the 3, divide by 3, greater than or equal to 1.
Yeah.
So how do I say that it can't be 2, but it can be greater than or equal to 1?
It'd be
1 to,
1 or bracket 1 comma parentheses 2. Or 2.
and then pick up on the other side, 2 to,
infinity.
y'all see that? You can put a union or a comma in there. Does that make sense? So everything bigger than 1, but then skip the 2. So it's like going from 1 to infinity, but not the 2. Now this last one, throw in a little curveball as you see. Oh, that's a domain right here. Now how do I do zeros?
It'd just be parentheses 2.
Hold on, how do I do zeros? What's the idea? The 0 is where the top is 0. So just take the top, set it equal to 0. So square both sides, radical goes away. Add 3, divide by 3. X equals 1. What? Yeah, that's right. So my zeros are just 1. That's it. So there's one place where this is 0. There's all kinds of places that you're allowed to plug numbers in.
So do you write, like, if it says determine the zeros in the domains, you write that and then you write x equals 1?
That's the domain. That's the 0.
So that would be your answer.
That'd be it. And then last one, again, don't memorize, think. How do I figure out domain here?
Can't have a 0 on the bottom, so
Can't have a 0 on the bottom.
it's
Can't have a negative under the radical. So no zeros on the bottom, under the radical, positive. Now, no zeros on the bottom means the bottom can't be 0. Are you with me?
Yeah.
But then also, stuff under the radical has to be greater than or equal to 0. But I can't let it be 0 because now it's in the denominator.
So is it just, wait, so why is it great? Oh, yeah.
So technically I can't do that, but I would have found that out here, right? So in this case, but think, bottom can't be 0, stuff under the radical greater than 0. Now I always have people look at the top and go, but what about the top? What about the top? What about it? I have never been concerned with the numerator when it comes to the domain. The only time I was concerned with it here wasn't because it was in the numerator, it was because it was under the radical, right? So don't get it in your head, oh, I gotta set the numerator equal to 0 too. That has nothing to do with domain. Domain is all about denominators not being 0 and stuff under radicals being positive. At least at this point in your career. You're gonna get to logarithms, and there are places where logarithms are defined. You're gonna have to add that to the whole mentality. Trig functions, there's vertical asymptotes on some trig functions, on most of them. You're gonna have to add that to your arsenal of places where the domain gets messed up. But anyway, can I solve this?
Yes.
Square both sides.
X minus 6.
Add 6 divided by 3.
X equals 2.
So you can't have a 2, but also what?
Same thing. 3x.
X is bigger than 2, so if you can't have 2 and it's bigger than 2, what do you end up with?
Parentheses around 2.
So parentheses around 2 to infinity? That works, right?
Well, yeah, because it can't be negative. Sorry.
Does that make sense? And then the zeros for this, what would you do?
X squared minus 25 equals 0.
Set the top equal to 0. So for zeros, I don't have to worry about that. Set the top equal to 0. You can factor it, but since it is a perfect square, I can just add it and square root it, and don't forget the plus or minus. But are those both my zeros?
No, because it can't be negative.
Can't be negative, so you have to exclude the negative and say just positive 5 because of that domain issue. Negative 5 would be outside that domain. Not too bad? All right. I don't know if this shows up tonight, but if it does, or maybe it did last night, did you remember seeing any problems like this in your homework at all yet?
Not in our homework last night.
Gotcha, okay, it's coming probably. I'm just gonna throw it out there because we got a couple minutes. What is this telling you to do? In a nutshell,
Divide again.
do a bunch of division stuff, it looks like to me, right? What do you think the length of those bars are helping you see? The length of those.
What to divide first?
Where to look first? So basically, this one being longer, basically splits the top and the bottom, doesn't it? So that would mean, okay, I've got this to worry about. But then of this, which is the top part of that, which one's bigger?
The second one.
That? So that kind of puts that together, doesn't it? So let's think about this, and don't rush. What is x to the 5th over x squared? Over x cubed. X squared, so all of that becomes an x squared. So I'm just going to bring this down. And then what's x to the 10th over x cubed?
X to the 7th.
X to the 7th? Now it's going to be really tempting for a lot of you to take this and cancel those. But I'm not going to jump the gun because I'm sticking to my math. And if I do, I'm going to be wrong because it ends up being x to the 14th on the bottom. If I were to divide by a number, I multiply by its reciprocal, which would be 1 over x to the 7th. They don't cancel. It's kind of like this. People miss this all the time too. 1/2 divided by 2 is 1. Really? I have a half a pie. I divide it into 2 parts, and now I have a whole pie. That doesn't even make sense, does it? But it's very easy to do that if you're. That is not true, and neither is that going to cancel. But what is x squared over x to the 7th?
X to
1 over x to the 5th?
Oh, yeah.
So that gives me 1 over x to the 5th, bigger bar, x to the 7th. And now, to divide by a number, what do I do?
times 1 over.
Multiply by, its reciprocal. So I end up getting 1 over
X to the 12.
x to the 12th. Be really careful about those. I love to throw a couple of those on your test, but I normally don't talk about them because it's some obscure homework problem that people don't check and correct. But it's all about recognizing which is the longest parentheses. And then once you recognize that, you can put parentheses in group and simplify a little bit at a time. Y'all have a good one.